Okay, now we're going to jump to 8.5. And 8.5 historically is a pretty easy section because it's just, there's no new factoring or anything like that. It's solving equations the way that we already know how to solve equations. And remember, now we can solve equations three ways. We can solve it by factoring. We can solve it by completing the square. And we can solve it by the quadratic formula. You can also solve it by graphing, but we're not going to do that today. So factoring, completing the square, and solving the quadratic formula. Well, there's some problems that don't look as pretty as our quadratic equations. Remember, ax squared plus bx plus c. Some don't look this pretty, and so we have to adjust them to where they do. Okay? So let's look at this. I've got a problem that's x to the fourth minus 9x squared plus 8 equals 0. Okay? Now, this doesn't look like my normal formula, and so technically I wouldn't be able to solve it. Okay? But if I used a substitution and I said that maybe this variable, I want it to be this, right? Just one single variable, but it's x squared. Well, what if I said that I created some letter u, and u equals x squared, whatever this middle term is, u equals x squared. Well, now let's try to rewrite it. Instead of x to the fourth equals x squared squared, right? And so instead of x to the fourth, I would write u squared. Okay? And then this would be minus 9 times, instead of x squared, I would write u plus 8 equals 0. So all I've done is I've chosen this to be my new term, and I've replaced it with a u, and here it's u squared, right? So now I have u squared minus 9u plus 8. Now can I solve this? Of course I can. I'm going to do this by factoring. Minus 8, minus 1. Perfect, we all know how to do that. So u equals 1, u equals 8. We're geniuses. Okay? But I still want to find out what x is. So now what I'm going to do is I'm going to plug x squared back in. So x squared equals 1, x squared equals 8. Now I'll solve both of these. So x equals plus or minus the square root of 1. So x equals plus or minus 1, right? Or x equals plus or minus the square root of 8, right? I can take a 2 out. So x equals plus or minus 2 times the square root of 2. So I have 1, 2, 3, 4 answers for this. And that makes sense because what's the degree of our original problem? It's 4. And so I need to have 4 answers. So that makes sense. Now, this might seem a little confusing, but the more that you do it, the easier that it will be, and it'll make more sense, okay? Basically, every time I want it to look like a quadratic equation, but sometimes it doesn't. So let's try again. And remember, like in the store, all of these are priced to sell. All of these are made to be solved. So they should really work out for you, okay? So it doesn't look like what I want it to look like, right? So let's change this middle guy to u, okay? So u equals square root of x, and it's always, always, always going to be the middle guy that you change, all right? That's going to become u. Whatever the variable is, construction for that, that's what you're going to change. So u equals the square root of x. So what would this be? Well, x equals square root of x squared, which makes sense. This is always going to be u squared. The way that these are shaped together, it's always going to be this is u squared, okay? Minus 3u minus 4 equals 0. U minus 4 plus 1, right? That's negative 4. That's negative 3. So my answers are 4 and negative 1, okay? But I have to go ahead and put it back in here, right? So it's actually u equals these things. So square root of x equals 4, and the square root of x equals negative 1. Okay? Squared, 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 squared. Okay? So x equals 16, x equals positive 1. Now let's plug it back into the beginning and see if that works. So 16 minus 3 times the square root of 16 minus 4. 16 minus 3 times 4 minus 4. 16 minus 12 minus 4 equals 0. Done. Let's try the other one. 1 minus 3 times the square root of 1 minus 4 equals 0. 1 minus 3 times 1 minus 4 equals 0. 1 minus 3 minus 4 equals 0. 1 minus 3 is negative 2 minus 4 is negative 6. It does not equal 0. So this is the only answer. And that makes sense because look at the degree of our original equation. It was 1. So there should only be one answer, usually. Okay? So that's just another example, and I'll do one more just because I can tell that you are loving this. T to the 2/5 minus t to the 1/5 minus 2 equals 0. Okay? So u equals t to the 1/5. See how I did that without even thinking? It's because it's always going to be that way. And this, if there's not a number up here, if there's a number I bring it down. If not, this is just going to become u squared. Right? And that makes sense, right? Because t to the 1/5 to the power of 2 equals 2/5 because of the power rules, right? So that's going to be minus u minus 2 equals 0. All right? U, negative 2, positive 1 equals 0. So 2 and negative 1, right? And that's what u equals. And so t to the 1/5 equals 2. T to the 1/5 equals negative 1. To the 5th power, to the 5th power. Remember, I'm taking this all to the 5th power to get rid of that 5th root, right? So that makes that t equals 2 to the 5th power is 32. T equals negative 1 to the 5th power is negative 1, right? And then I can just plug it in and double check. So if t equals 32, then that's going to be 4 minus 2 equals 0. Check. And if t equals negative 1, that is going to be 1 minus negative 1 minus 2 equals 0. 1 plus 1 minus 2 equals 0. Check. So both of these are correct answers. All right? And that's it. It's just recognizing that we need to sometimes adjust to make quadratics. So determine what u is, which is always going to be whatever this middle term is. Recreate it, just like this. Factor it, complete the square, do the quadratic equation, whatever you need to do to get the answers, and then set them back equal to the original, right? And solve. That's it.